A model for the yield y of n for an agricultural crop is a function of the nitrogen level n in the soil. This model is y of n equals kn divided by the sum of 49 on n squared, where k is a positive constant. Which nitrogen level maximizes or gives the best yield? To maximize y of n, we'll need to determine the critical numbers, which is where the first derivative is equal to 0 or undefined. To determine y prime of n, we will have to apply the quotient rule. For the derivative of y of n, the denominator is equal to the square of the denominator of y of n, which gives us the square of 49 plus n squared. And the numerator is the denominator of the quantity 49 plus n squared times the derivative of the numerator, which is the derivative of kn with respect to n. Remember here we're treating k as a constant. And then we have minus the numerator of kn times the derivative of the denominator, which is the derivative of 49 plus n squared with respect to n. And now let's find the derivatives. We have y prime of n equals, we'll leave the denominator the same, which is the square of 49 plus n squared. In the numerator, we have the quantity 49 plus n squared times the derivative of kn with respect to n, which is k times 1, or just k. And then we have minus kn times the derivative of 49 plus n squared with respect to n, which is 2n. And now let's simplify the numerator. Distributing k, we have 49k, and then plus kn squared, and then minus 2kn squared. Combining like terms, we have 49k minus kn squared. And this is still over the square of 49 plus n squared. And now we need to determine where the derivative is equal to 0 or undefined. There are no values of n where we have division by 0 or the derivative is undefined, and therefore we find the critical numbers by setting the derivative equal to 0 and solving. A rational expression is equal to 0 when the numerator is 0 and the denominator is non-zero, which means we determine the critical numbers by setting the numerator equal to 0 and solving for n. So we have 49k minus kn squared equals 0. Let's factor out the common factor of k, which gives us k times the quantity 49 minus n squared, which is a difference of squares. Factoring, we have k times the quantity 7 plus n times the quantity 7 minus n. 7 plus n is equal to 0 when n is equal to negative 7. And 7 minus n is equal to 0 when n is equal to positive 7. But remember, n is the nitrogen level, which can't be negative, so we can exclude n equals negative 7. We only have one critical number, which is n equals 7. From here, we need to determine whether y of n changes from increasing to decreasing at n equals 7, meaning the first derivative changes from positive to negative at n equals 7. And let's do this using the table above. Again, assuming n can't be negative, the first interval for n will be from 0 to 7, and the second interval will be from 7 to infinity. Now we'll pick a test value in each interval. Let's select n equals 6 and n equals 8. And next step is to determine the sign of y prime of n when n is 6 and n is 8. Y prime of 6 is equal to 49k minus k times n squared, where n squared is 6 squared is 36, giving us minus 36k, divided by the quantity, the square of 49 plus n squared, which gives us the square of 49 plus 36, which is 13k, divided by the square of 85. We can stop here. Since k is positive, this quotient is positive or greater than 0, the first derivative is positive over this interval. And therefore, y of n is increasing over this interval. And now we'll determine the sign of y prime of 8, which is equal to 49k minus k times n squared is now k times 8 squared, or 64k, divided by the square of 49 plus n squared is 64. Simplifying, we have negative 15k divided by the square of 113. Again, we can stop here. We know k is positive, so because we have a negative here, this quotient is negative or less than 0, and therefore the derivative is negative over this interval, indicating y of n is decreasing over this interval. So now we know the function changes from increasing to decreasing at n equals 7, and therefore we do have a relative maximum. So n equals 7 is the nitrogen level that will maximize or give the best yield. Before we go, let's verify our result by graphing y of n. Here I'm using Desmos to graph y of n, but I did replace n with x, so we have y equals kx divided by the quantity 49 plus x squared, and I created a slider here for k. If we look at the graph on the right, notice how we do have a maximum at x equals 7, which is really n equals 7, and as we change the value of k, notice how the location, or the nitrogen level, does not change. That maximizes the yield. So this graph does verify n equals 7, or a nitrogen level of 7 will maximize the crop yield. I hope you found this helpful.